Hey everyone, and welcome to this explainer. Today, we're going to unpack one of the absolute most transformative shifts in industrial history. We are taking a journey, really, from the chaotic, clattering world of physical wiring and mechanical switches straight into the sleek, high-speed era of smart microchips. If you've ever stopped and wondered how massive factories manage to coordinate literally thousands of moving parts without missing a single beat, well, you're exactly in the right place. We're breaking down relay logic versus programmable logic controllers, or as they're commonly known, PLCs.
So here's our roadmap for today. We'll quickly cover the evolution of automation, understand the basics of relay logic, explore the absolute power of PLCs, put them head-to-head, and then finally, wrap up with some real-world applications in Industry 4.0.
All right, part one, the evolution of automation.
So why did industries desperately need to evolve in the first place? Well, early manufacturing relied heavily on intense manual labor and some very basic mechanical control. It was slow, it was highly prone to human error, and honestly, it could be pretty dangerous. As factories started growing, they needed a way to control increasingly complex machinery automatically. They needed a system that could actually think and react on its own. Okay, let's dive into this by defining our two heavyweights. At its core, relay logic is an electromagnetic, hardware-based control system. You're dealing with physical, moving parts to control electrical circuits. On the flip side, a PLC, a programmable logic controller, is a software-based control system. So instead of relying on all those mechanical switches, it uses a microprocessor and coded instructions to tell a machine exactly what to do.
Moving on to part two. Understanding relay logic. To truly appreciate our modern systems, we kind of have to look at the legacy tech that paved the way. Relay logic is incredibly tactile. It relies on a few key physical components. Basically, you've got a coil, which acts as an electromagnet. When a sensor or a push button sends power to that coil, boom, it creates a magnetic field. This field then physically pulls on metallic contacts, switching them from normally open, meaning the circuit is broken, to closed, or shifting normally closed contacts to open. You pair these up with mechanical timers and heavy-duty contactors, and you've built yourself a basic mechanical brain for your machine.
But, oh man, here is the massive problem. Imagine building a complex machine that requires hundreds of these physical relays to function. Your control panel quickly becomes an absolute nightmare of spaghetti wiring. We're talking miles of complex, tangled cables. And if just one single relay coil burns out, no way. You might spend hours painstakingly tracing wires just to find the one culprit. It was expensive to build, incredibly time-consuming to alter, and a total absolute headache to troubleshoot.
Which brings us to part three, the power of PLCs.
This right here is where the industrial world got a massive, revolutionary upgrade. A PLC operates using something called a program scan cycle. You can think of it as this continuous little micro-story of how the machine thinks. Step one, it reads the inputs. It checks all its sensors to see what's currently happening in the physical world. Step two, it executes logic. The CPU runs through its software program and decides, okay, based on these inputs, what should I do? And step three, it updates the outputs. It sends out an electrical signal to actually take action, like, say, turning on a motor. And the crazy part? It does this entire cycle thousands of times per second.
So how does this microstory build into the actual physical architecture of a PLC? Well, instead of massive walls covered in individual relays, you get a sleek, consolidated unit. You've got your CPU and memory acting as the brain. You have your power supply, you have communication modules to talk to other networks, and, absolutely crucially, you have your digital and analog input/output modules. This elegant digital brain completely, 100% replaces the chaotic physical wiring of the past.
Section 4, Relay versus PLC. Let's put them head-to-head.
Now that we've got the basics down, it's time for the ultimate comparison. And this brilliantly illustrates the exact trade-offs between the two. When it comes to flexibility and performance, PLCs absolutely dominate. The wiring is vastly simpler, the programming can be changed in seconds just using software, the execution speed is basically instantaneous, and having software diagnostics makes troubleshooting an absolute breeze. So, where do relays actually win? Initial cost. For a very basic setup, just buying a few physical relays is definitely cheaper up front than investing in a PLC microprocessor.
So, which one do you actually choose? Honestly, it comes entirely down to scale. Relays are still perfectly viable, great even, for small, isolated systems on a really tight budget where you just need simple on-off control. But the very moment you start talking about large factories, multi-machine coordination, or literally any kind of smart automation, PLCs are the absolute gold standard. You simply cannot scale efficiently using physical relays.
Now, for all the aspiring engineers and technicians tuning in right now, here's some insider knowledge that is going to save you hours on the factory floor. The most common mistakes people make when working with these systems, they're completely avoidable. We're talking about choosing the wrong input/output modules for PLC, basic wiring errors that end up shorting out systems, overloading physical relay contacts with way too much current, and logic errors in the PLC programming itself. So always double-check your loads, and please always test your logic and software before you ever run it on physical hardware.
All right, part 5, the real world and future.
Let's take all of this theory we've been talking about and look at how these systems are actually running the modern world all around us. Seriously, you interact with both of these technologies every single day. Simple relay setups might still be out there running basic motor starters or simple water tank pumps, but PLCs, they're the ones running the high-speed conveyor systems you see in those massive distribution centers. They're ensuring precise timing in high-speed packaging machines. They're managing entire citywide traffic signal grids and even coordinating massive smart irrigation networks for agriculture.
So the crucial point is this. A PLC does a whole lot more than just control a machine. A PLC acts as a massive data generator. Because it's essentially a computer, it offers immense advantages, like remote monitoring from literally anywhere in the world. It allows for SCADA integration for total facility visualization. It logs operational data so you can predict maintenance needs before something breaks, and it connects directly to the Industrial Internet of Things, or IIoT.
And finally, Section 6, the future of smart automation. We're no longer just automating isolated machines anymore. We are moving rapidly into Industry 4.0, where entire factories are interconnected, they're self-monitoring, and they are completely driven by data. Now, what's really interesting about this slide is how companies like Devi Automation Solutions are actively bringing all of this together. Their entire model is built on taking these advanced PLC and automation capabilities and then integrating them across totally diverse sectors. They don't just focus on standard industrial automation. They apply these smart technologies to home automation, cutting-edge AI and IIoT solutions, and even smart agriculture. It's just a perfect showcase of how moving away from simple, clunky relays to intelligent, programmable systems paves the way for a much smarter, better tomorrow.
And well, that brings us to the end of our journey today. From the noisy, wire-heavy panels of the past, all the way to the sleek, interconnected digital brains running modern factories, automation has just completely transformed. So I want to leave you with this question. As we push deeper and deeper into an Industry 4.0 world, which technology will define your next automation project? Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.